In this video, we are going to discuss motion where the acceleration is constant. Or in other words, the acceleration stays the same value the whole way through the motion. And this allows us to have what we call the kinematic equations. So I'm going to give you these list of equations and talk about them a little bit. Our first one here states that velocity final equals velocity initial plus acceleration times time. Now what this tells us is that velocity initial is going to be a given property, and the acceleration is going to be a value. It's going to be the same value, so that as time increases, this velocity over here is going to increase. And if this is a deceleration or negative, this velocity over here is going to decrease with time. And because time is raised to the first power, this is going to be a linear relationship. Our next kinematic equation is going to be that the displacement is equal to 1/2 velocity final plus velocity initial times time. Now be careful, this one does not have acceleration in it, but we're still assuming that the acceleration is constant, because this relationship comes from the idea that when acceleration is constant, the average velocity is equal to velocity final plus velocity initial divided by 2. This is only true, though, if the acceleration is constant. Our next relationship here is that the displacement is equal to velocity initial times time plus 1/2 times the acceleration times time squared. Now if we look at this relationship, velocity initial would be your initial velocity, so it's not going to change. Your acceleration, we're assuming, is a constant value. So this value and this value, the time, are what's going to change with time. But since this t here is squared, your displacement actually has a parabolic relationship with time. So it's not going to be a linear relationship, it's actually going to be a curved line if you were to plot it. And your last relationship is that the velocity squared equals the velocity initial squared plus 2 times the acceleration times the displacement. Now I presented the equations in the traditional form that they are presented, but keep in mind that you can algebraically rearrange any of these formulas in order to solve for a different variable. So there's going to be a lot of algebra from here on out. You should also notice which equations do or do not have certain variables. So this first one here does not have displacement in it. So if you have a problem without displacement given, you should start here. This is the only equation without time in it. So if you have an equation or a problem where you're not given time, this is probably the relationship you want to start with. So you want to know what is in these equations, what's not in these equations. Now the next video in the list is going to be your first example problem with these concepts. Whenever you read the problem, the first thing you want to do is read the problem the whole way through. And then you want to start picking out what you know and what you don't know and what you're looking for. So if you're given velocity, you should write that velocity down. If you're given time, you should write that time down. If you're looking for the acceleration, you should write down an A with a question mark next to it. So you can start pulling apart the word problem and identify what information you have and what information you're looking for. You can then match that information you have and what the information you're trying to find to a specific equation. And you have a very limited number of equations at this point, which is why we're stopping here and doing some example problems. Whenever you show work in this course, you want to start by writing down the equation you're going to use. Then you should plug numbers in, and then you should start your algebra. And at the end, you should have an answer with units.